Okay, na? By the way, in the last class, we did not had enough time, like the time was ending, so we could not discuss your doubts. Abu Bakr,
Yeah.
sorry, Habib, I mean to say. Yeah, what was your doubt again? Tell me.
Wait, I'm being in my notebook.
Okay, bring it. By the way, Habib, you should keep everything with you once you attend the class. And
Yeah,
look,
I kept, but I forgot to keep my homework notebook.
okay, no worries. Okay. So that was from in that aesthetic consideration and infographics. From that topic, you had some difficulty, I suppose. Okay. So about the ray, we have learned in the last class, right? We learned that ray is basically a portion of a line that starts at one point, right? That is called as the starting point or the initial point. Okay, and it goes endlessly in any direction. And we have so many daily life examples that gives us an idea about the ray. Like you would have seen the lighthouse, right? No, like you would have seen the lighthouse like this.
It starts from one point and ends. Um, it doesn't end. I mean,
Exactly. It has a starting point, but does not have any end point like this. Or you could have some other examples like the torchlight. That also, no, the torchlight.
uh,
So
Sun rays.
sun rays also very good. So what we are seeing that the sun's rays have a starting point, but there is no end point to it. Now the sun's rays are emitting out of the sun in all the directions like this. Okay, sun's rays. So lighthouse, torchlight, and sun rays. Okay. Habib, you have opened your doubt.
yes.
Tell me. Let me also open the question. I have opened it. Yeah. Tell me which question number.
Oh, I should open the PDF. It's not. Oh, wait. Sorry.
Basically, tell me in which question you are finding you had difficulty. Like as I was
In
checking your
all.
assignment in all the questions. Huh.
Yes.
Okay. Okay. See, the first question that was there in the PDF was that which of the following is not a key feature of a good infographics, right? Which of the following is not a feature of a good infographic? The features of the good infographic is like there should be clarity in it, right? It should be clear, it should be accurate, and it should be simple to understand. But option B there is, if you have opened the question paper also, like the assignment PDF, option number B is there written as colorfulness only. No, colorfulness only is not the key feature of the good infographic. Like you use so many different bright colors, okay, we use it, but that is not the only good feature. Now, understood what the question is saying?
Yes.
Okay.
Yes.
Since second question it is saying that in a bar graph, bars should be in a bar graph. You guys tell me these bars should be. The options are saying that option A is unequal in width. Should it be like that? One bar is this much in thickness, another is this thick. Huh? It should not be unequal in width, no? Then should the bars
Yes.
should be touching each other? Laksh, you tell me, should the bars touch each other?
No, sir.
No, right? So they should be equal
Oh,
in
sorry.
width.
That's double bar graph.
Yeah, that's a different thing, but there also that's a different thing, by the way, double bar graph. So it should be equal in width and evenly spaced. The width is same and they are having equal spacings between them. And they should they be drawn diagonally like this? That is also false. No? So option C is correct for this. Okay, Habib. Then third
Yes.
question, it is saying that what is an infographic? Why is it important to present data in a visually appealing manner? Give example. So this question, like I have described to you, like what is an infographic? Yeah. So you guys should be able to answer this. Like infographic is the visual representation of data or information that is designed to present information in a clear and appealing manner. Basically, it's a visual representation of the data where we use charts and colorful different colors to represent the data. That is what this infographic is. Okay, now then one more question is there. What was the question? Yeah, you have to design a bar graph to represent the number of students using different modes of transport to school. So this one you could have done yourself. Like what you could do, like you can say that there are, let's say, 20 students in your class. 5 of them, let's say, uses bus to commute to the school, to go to the school. 5 of them uses car, 5 of them uses a bicycle, or 5 of them prefers metro, or let's say different numbers. So then you could have drawn a bar for this. Lux, you're getting it. Like suppose in your class there are 20 students. Okay, let's say 8 students goes by car. Okay, then let's say there are 5 students who goes to school by metro, and there are, let's say, 7 students that goes to school by bus. So then you can prepare a bar graph for this. No, that is not that difficult, right? Getting it? Where you would say that 1 unit equals to 1 over here. Like these are the total 20 students here, right? These are the mode of transport, the different modes of transport taken by the different number of students. So 1 unit equals to 1 mode of transport. Okay, now. So here you could have drawn it in the following manner, like car, then bus, then a metro. So how many students travel to school by car? So 8, like this. Then metro 5, then bus like 7, and here you would have made the marking like this, like 1, 2, 3, 4, 5, 6, 7, like that. Getting it, Habib?
Yes.
Okay. Okay, so that was all about the race. Sorry. Now we are going to learn about the different type of angles. That is angles. Now say that you have taken 2 rays. Okay, now also one more thing, sorry. One thing was left to discuss about the ray. Like how do we denote ray? So it is denoted as follows. Like if we take a line like this, if we take a portion out of line, okay, and you know that array is basically a portion of line that has a starting point and it goes endlessly in a given direction. And let's say this is A and it is endlessly going in this direction. Let's call this as P. So it will be denoted in the following manner. You write AP and write an arrow on top of it like this. So in this manner, it is denoted. Okay. Let me put this screenshot. Okay. Talking about the angles. Say that you have taken 2 rays like this. This is a ray. Okay. And we have taken another ray also. Say this is also a ray. All right. Now, what if these 2 rays were to, like, the end point or the starting point of these 2 rays were to be common? Like let's say this is ray OP and this is ray OQ. What if these 2 end points were to be common, like it were to fall on top of one another right now? So then you will basically a angle will be formed when 2 rays will meet at a common end point. That will be forming an angle like this in the following manner. It will be kind of looking like this now. Right, so that is O, ray OP and ray OQ meeting together at the point O, at the common endpoint O. And by the way, this common endpoint O here, common endpoint O here is the vertex. What do we call this? Vertex. Okay. So whenever two rays will be meeting at a common endpoint, that common endpoint, we will be calling this as the vertex. Okay. Further, how do we measure this? Like it will be having some measurement now, right? This angle must have some measurement. Getting it? So that measurement is measured in degree. Okay, now it is measured in degree. So measured in degree, and the symbol is simply this. Okay, in this manner it is written. Further, this angle here has some parts. Like now, there are two parts of the angle. Like these rays OP and ray OQ, we are calling them as the arms of the angle. While this point O here, the common end point of these two rays, that is called as the vertex, which I have written over here. Tell me if that much is clear to everyone.
Yes, sir.
It is? Okay. Now, sometimes someone may ask you to define angle, like how do you define angle? So you will write down that an angle is formed when two rays meet at a common endpoint. Common endpoint called as the vertex. Okay. Then angles are measured in degree. Measured in degree. Like some examples, you can take examples like 30 degree, 135 degree, 360 degree, etc. Okay, etc. Then as I said that an angle has two parts, namely the arms and the vertex. So parts of an angle. So first part is the arms. So by arms, we basically refer to the rays, the two rays that come together to form an angle. So the two rays that forms the angle. Is there some background noise coming from my side?
No, sir.
Oh, okay, that's good. There was some noise in the street. Okay, so that is the arm. So can you guys tell me what will be the arm of this angle? Arms will be the ray OP and ray OQ, no?
Okay, yeah.
Right, Habib? Right, Laksh?
Yes, sir.
So for example, ray OP and ray OQ. These are the arms of the angle. Second thing I say that it's the vertex. Vertex. So vertex is basically the common end point of the two rays. That is the vertex. So the common end point of the two rays is called as vertex. Okay. Like example, vertex
Point.
O. Okay, now
Vertex.
vertex O. Okay. Let me send the screenshot of this much. By the way, I assume that this much should be clear to everyone.
Yes, sir.
Okay. Good. Now further, there are different types of angle. Many of you would have, many times you guys would have learned about this, I suppose, right?
Yes.
So types of angle, types of angles. Okay. Yeah. So basically there are different types of angles. Okay, now like you have acute angle, right angle, obtuse angle is there, reflex angle is there, complete angle is there, right? These are different examples of the angles. So angles are classified into different types based on their measurement. So let's quickly learn about them. It's not a big topic. So we have got acute angle, right? You can clearly look at this like this is symbolizing acute angle. So an acute angle is an angle that is less than 90 degree, right? Also, you guys should know that when we say an angle now, whenever I say angle, so basically an angle is the amount of turn, basically. Amount of the turn will be the size of the angle. Like so, like basically means that this amount of the turn. Now I suppose there might be some background noise. Is there? Please tell me if this.
Yeah, there's a little bit.
Just 1 minute. Give me 1 minute. I'll be back 1 minute. Yeah, I'm back. Yeah, so we're saying that about this angle. See, basically, an angle is the amount of the turn here. Like, suppose if this ray here, let's name this as OM and this as ON. Okay. Now, you guys tell me if this ray OM were to make a turn so that it falls directly over ON. So it has to take a turn now, right? If OM has to directly fall over ON, so it has to make a turn. Like suppose these are 2 pens in my hand. Let's say that these are the two rays. Okay. Now, if this black pen in my hand has to go directly over the blue pen, okay, so it has to make a turn. See, it has to make a turn now so that it comes right next to ON. So that should give you an idea about the angle. Hope you guys are getting it.
Yes, sir.
Yes.
Okay. So that is the important thing over here. Yeah, about the acute angle, you already know that an acute angle measures less than 90. Acute angle measures less than 90 degree. Examples are so many like 15 degree, 30 degree, 60 degree, etc. Next, we have got the right angle. So about the right angle, the thing is that an angle that has an exact measurement of 90 degree, that is called as a right angle. So an angle measuring exact 90 degree is called a right angle. Okay. Also, you see that it forms a perfect L shape. If you see here, it's forming a perfect L shape. Okay, now so that is right angle. Okay, and this like there are so many things that you can observe in your daily life that resembles 90 degree angle, like the corner of a square, the corner of a rectangle. You see the corner of a notebook, the
The
edge of a
corner of a
table,
table,
the corner of a table, right?
the
That
corner of the ground and the wall.
exactly right now. So that basically represents a 90 degree angle. Sorry. Next, we have got obtuse angle. So obtuse angle, you see, if you were to look at the staircase and the ground, let's say, or basically, let's say that this is the staircase. Okay. Say that this is the staircase and that's the floor. Now you look at the angle between the staircase and the floor, this much of angle. right? So it is clearly more than 90 degree now, right? Because if you see 90-degree angle, so 90-degree angle is exactly like, it kind of looks like this now. That is 90-degree angle, right? And it is more than 90 degree. So obtuse angle is an angle which is more than 90 degree, but less than 180 degree. Okay. An angle measuring more than 90 degree, but less than 180 degree. Okay. Can you guys think of few more examples of this obtuse angle? Yeah. Just think of some examples of obtuse angle from day-to-day life. You see angles formed by the hands of the clock at different time. There you can have some example. Like suppose,
The knob, no, that's more. That's less.
let's suppose the time right now is 8 o'clock, right? 8 o'clock, let's suppose. Okay. So you look at the minute hand and the hour hand. If you have an analog clock at your home, analog clock is the one in which the hands are there, right? No, the circular one, right? The circular clock. Okay, not the digital one. So if the timing is 8 o'clock right now, suppose, so then you look at the position of the minute and the hour hand, like where they are situated. So we find that this is where the hour hand is going to be, and this is where the minute hand is going to be at 12, and this is at 8. So isn't this more than 90 degree, right? Because 90 degree would kind of look like this now, will form a perfect L shape, but it is clearly more than 90 degree. Getting it, everyone? Okay.
Yes, sir.
Okay. Look at the fan. Look at the fan. And look at the blades, angle between the blades of the fan. Ceiling fan, I'm saying. Look over there. What do you think? What is the angle between the ceiling, between the blades of the ceiling fan? Yeah. If you to look at the angle between the blades of the ceiling fan, right? So that is also actually forming an obtuse angle. No? Getting it, everyone? What I'm trying to say?
How?
Yes, sir.
Just I would say just take a look at the if the fan is not running. Suppose if you turn it off, so you will see that the angle between that will also be equal to 180 degree. Okay. Also, it depends upon the design of the ceiling fan. Also, like what's the design, but usually we can observe it there as well. Okay. Or also, if you were to look at the reclining sofa, right? Reclining sofa, reclining chair, right? If you are reclining on the chair like that, so then like when you are completely reclining like that, kind of this, so then also obtuse angle is formed. Hope you guys are getting it so far.
Yes.
Okay. I think this example of the
Yes.
ceiling fan might not be a better example. Okay, na? But actually also, like the blades are not perfectly at 90 degrees. So this example can be taken as an example of obtuse angle from our day-to-day life, day-to-day things we observe. Okay. Next is the straight angle. Now, suppose if you were to take two right angles and merge them together, then won't you get a straight angle? If you take two right angles like this right angle and another right angle. Okay. So 90 plus 90, that's going to be 180,
180, 180.
right now. So a straight angle is formed which has a measurement of 180 degree. Getting it now? Okay, hope that much is clear to everyone.
Yes, sir.
So an angle that measures exactly 180 degree, that is called as a straight angle. Straight angle. So an angle that measures exactly 180 degree is called a straight angle. Okay, it's called as a straight angle. All right. Now there are so many examples. There are so many examples of this straight angle, right? Now, like suppose what?
Upper part of the desk,
Hmm? Look
the
at the
flat surface of the notebook,
yeah, right.
the pages also.
The edges of the table, right? Or the angle formed by the hands of the clock at 6 o'clock, right? At 6 o'clock, where are the hands of the clock going to be? Like this one is going to be over here,
Yes.
okay, at 6, while the other hand is going to be at 12. Okay, now that's 3 and that's 9 over here. So the angle form here is 180 degree. From both the sides, it's 180 degree. Getting it?
Sir, also the flat screen of the phone, tablet, or laptop and TV.
Anything, anything that is flat, so there a straight angle is formed. Okay, now anything that is straight, that is flat. In fact, the name itself is straight, like so straight figures, straight objects would be forming a straight angle simply. Okay. Also, important thing to note down is that okay, straight angles can be formed. Angles can be formed when two right angles are drawn adjacent to each other. Adjacent means right next to each other, okay, na? Side by side in this manner. So you take a 90-degree angle, you take another 90-degree angle, or basically right angle like this, okay? So thereby 90 plus 90, a straight angle is formed. Hope you guys understand that, okay? That's the thing. After this, we have got the reflex angle. If you have noticed one thing, so far, the different angles which we have been discussing, all of them are in an increasing order actually, right? Like the acute angles, they are less than 90 degree. Right angle is exactly 90 degree. Obtuse angle is more than 90 degree, right? It's more than 90 degree, but less than 180 degree. Then a straight angle is exactly equal to 180 degree. Further about the reflex angle, it's more than 180 degree, right? No?
Less than 360 degree.
Exactly. So an angle that measures more than 180 degree but less than 360 degree is called a reflex angle. So give some examples of it. Give me some examples. Think of some examples of this. Like like
The clock at
190
11
degree.
o'clock.
We will take some real life examples. Let's take the numbers.
The, like the clock when it's 11 o'clock and 10 o'clock.
11 o'clock and 10 o'clock.
Yeah, like reflects.
Oh, like that you are saying. Okay. Also the hands of the clock at 10:10, right? At 10:10, like I mean to say, in this manner. Hold on. 12, 11, and that's 10. That's 9 over here. And that's 3. That is 6, 1, 2. Okay. So if the we take the hands of the clock at 10:10. Okay. No, so 10:10, one hand is going to be over here. One hand is going to be slightly over here. Now you take the outer part. I'm asking you to take this part over here. Okay, now this part. So won't that be more than 180 degree, right? It's more than 180 degree.
Yes, sir.
Okay, not the inner part, but the outer part, the one I have circled. So that is a
Yes.
reflex angle. Okay, now, and we have so many examples of reflex angle. Okay, now? So that is the thing. After this, now we are having the complete angle, right? That's his complete angle.
Complete angle as a angle measure of 360 degrees.
Exactly. So an angle measuring 360 degree is called a complete angle. Okay. Or let's say that we take two straight angles. Two straight angles we take two straight angles such that we take this one, okay, and we take another straight angle like this, okay. And now what if both of them were to be merged together? Okay, now so then it will kind of look like this after they are merged together. Getting it now? And that is the center point, by the way. Getting it? So that is a complete angle. Getting it, everyone? So that's complete angle and having a measurement of 360 degree. While in this one you had just two straight angles. When they were mixed together, when they were combined, so you got a complete angle. Okay. Also, basically around a given point, angle of an angle of 360 degrees formed around a given point. Also at the center of the circle, the angle formed at the center of the circle is also complete angle, or basically 360 degree. Getting it, everyone, what I'm saying? Okay, now? So a full circle forms a complete angle. Or
Sir, can you
the
repeat the last part again?
I was saying basically that a complete angle basically measures 360 degree. It represents one full rotation or revolution. It will form a perfect circle. If you were to look at this, it's forming a perfect circle now. All the different angles which you have seen so far, look at this. Like, is this angle forming a perfect circle? No, neither
No,
this
sir.
one, not this one, even not this one, even the reflex angle is not forming a complete circle. But in this
Yes.
case, you are seeing that in this case, a complete circle is formed now, right? So we can represent it in the following manner. Like we can draw it in the following manner. Like it will kind of looks like this, right? Okay. Also, there's one more interesting concept. Let me tell you about that also. Okay. Now, suppose again with the help of the pens or something, let's understand this. Okay, 1 minute. Yeah. Look at this. Okay, suppose these are two rays in my hand. Okay, now these are, hope you guys can see it, or let me take a different pen. Hold on. It's visible to both of you, right? So suppose I have taken two pens, like suppose these are two rays. Okay, now I am holding it in the following manner. Okay, let me zoom it out. Yeah, perfect. Now, if this rays were to rotate and rotate and rotate and rotate, keeps on rotating, rotates, and then ultimately rotates in this manner. Does a full circle, does a full circle rotation. Getting it, everyone, what I'm trying to say? Look again. So this ray, the red one, okay, now it's doing a full rotation. It's doing a full rotation like this. Getting it? So when it does a full rotation, look at this red one over here, right? This red ray has done a full rotation and is now coinciding over the blue ray, right? So then a complete angle is formed. Hope you guys are understanding this.
Yes, sir.
Okay. So that is the thing. That's your complete angle. Okay. And we have many examples, many examples from real life. Like when the wheel of the car rotates one full turn, when it does one rotation, so a complete angle is formed. When you go in a merry-go-round, you know about merry-go-round, right? So when it makes one complete spin, so it makes a complete angle. Got it?
And a
Mhm.
Ferris wheel.
In a Ferris wheel also, when it does a one complete rotation, so it makes a complete angle. Okay. So it represents one full, sorry, one full rotation. Okay, have I put the screenshots? Which was the last one? Okay, I have shared this one only. Wait. Okay. Now it's time to do some questions. So in the last class, we had done question number 2, question number 1, question number 2, okay, and question number 4 also. Okay, now question number 3 that was left to be done, I suppose. Yeah, it was left. So question number 3 is saying that name the rays shown in the given figure 2.5. Is T the starting point of each of these rays? Yeah, you guys try to answer this first, then I will explain.
Yes, sir. The answer is true.
Okay, but
T
what
is
are the
the
rays?
starting point.
Okay, that's correct.
The
And what?
rays are T A T N, and
Hmm.
also it could be T A and T B.
TN and TB and TA. Very good. Okay, hold on 1 minute. Just spill some water over it. 1 minute. Yeah. So let me just clean this, by the way. You guys have been noting down the answers also, no? You guys have noted down the answers in your text copy? Yes. Tell me if you guys have written it or not.
Yes, I have
Yes,
done
sir.
so.
Okay. So should I erase this? I'm erasing it. Okay. Okay. Now for question number 3, the rays are as follows. So we have got ray TA, so that we can write it in the following manner. Then ray TN and as well as ray TB. Good. And yes, all of them have a common starting point, that is T. So yes, T is the starting point. Okay, question number 4. This we had done, by the way. Question number 5. Okay, in this you have to name the 5 points, a line, 4 rays, and 5 line segments. Yeah, start. What are the different 5 points in this? It's simple. Tell me.
So the points are D, E, O, C, and B.
Obviously. Next, give at least example of one line.
Line DB.
Line
DB.
DB. Okay, good.
Four
And
is
give 4 rays in this. What are the 4 rays?
O D, O
Hmm.
B, O
Hmm.
C, and O E.
Oh, very good. And line segments.
D E, D O,
Okay.
D B, E
Hmm.
O, E B, O C.
Hmm. Awesome. Excellent. Okay, na? Or did you say OC? No, OC is a ray. It's not a line segment. Okay, na? OC is a ray, but not a line segment in this one. Getting it? Let me write all of this. So 5 points for you are as follows. So point D, E, O, C, and B. A line, you have given an example DB, and how do we denote it? With a symbol like this. There are 4 arrays in this total. So like OB, you see this? OB is a ray, OC is a ray, OE is a ray, and OD is also a ray, right? So ray OB, ray OC, then ray OE, and then ray OD. 5 line segments in this are as follows. So you have got line segment DE. But should I write it as DE only? Is there some error in it? ray EO, this one. Okay, no? Sorry, not ray, I'm saying line segment. Then you have DO, this from here to here, DO. Then you can take EB as well, ray EB, sorry, line segment EB, and then you can take OB. So there should be a line drawn over the top. That is the correct way. Okay. I guess that was the total number of questions in it. Or hold on. There should be few more questions. Guys, how many questions are there in the first exercise? I think there should be 6 or 7, I guess. Yeah, there's one more question, no? Yeah, Habib, tell me. Laksh, do you have the NCERT book with you?
No, sir, I didn't. I don't
Oh,
have.
okay. As I can recall, there was one more question. Okay, I'll be taking up that in the next class. Okay. Now you open the page 19, Habib. So can you find
Yes.
the angles in the given picture? In page number 19, we have this exercise. You have to draw the rays forming any one of the angle and name the vertex of the angle. Okay, let's begin with this. So,
I got about the box.
okay,
There are 4 right angles.
there are 4 right angles. That's correct. Okay, and
And yeah, that's acute angle. Wait, one.
we have to draw the rays forming any one of the angle and name the
There are
vertex of the angle.
6
There are
acute angles.
actually so many angles in this, but we have to name only one. If you see, here is also an angle, here, and here. 4 right angles, right, Laksh and Habib? At the center, like at this point, also an angle is being formed. No? Like, let me mark it.
Yeah, understood. That's
Okay.
a right angle.
Yeah, that's also right angle at the center. Getting it? So here again, angle is formed. Although there are so many angles here, like this is also in right angle. This 1 minute. Yeah, this is also in right angle. This one, right, and here also you're seeing an angle. You see here, and here. Like actually, the figure is full of angles, no? But we don't have to name all of it. We don't have to mark everyone. So draw the rays forming any one of the angle and name the vertex of the angle. So we can use any alphabets. Usually, in order to mark the starting point, we can use the alphabet O. Okay, it looks suitable. Then this OP, and you can call this as OQ. Ray OP and ray OQ are meeting at the point O to form this angle. And how do we name this? So pay closer attention to like how we are going to name this angle here, right? So first of all, you have to write the arms. Okay, now the arms are OP and OQ, right? These are the arms of the angle, isn't it? All right, no. And what is the vertex? Yeah, Habib.
Oh,
That is O. O is the
4.
vertex. 4.
Sorry,
Vertex. O. Okay. All right. So that is the vertex. Oh, yeah. Now, how do we name the angle? So, in order to name the angle, okay, you have to keep the vertex in the middle. Okay. You keep the vertex in the middle, and then on the left and the right, you can write the alphabets. The alphabets, remaining alphabets in this is P and Q. So either you can write this as angle POQ, or either you will write the vertex in the center, and on both the sides you can write the alphabets in this manner. Also, first you can write Q and then you can write P, angle POP. Both of them are basically representing the same angle. So this is the way how you have to name it. Tell me if you guys have understood this thing.
yes.
Yes, sir.
Okay, that's good to know. Okay. By the way, in this figure, the marking has already been done. We need to name the angle and the arms and the vertex. So tell me, what are the arms, vertex, and the angles? Actually, there are more than one angle in the cycle here. Yeah. How many angles do we spot in this? Guys, in this cycle, how many angles? This angle here, one,
There
and the
are three
second angle,
angles in the cycle.
and the one
Three
more,
angles.
that is three. Good. Okay. So first of all, if you were to talk about this, 1 minute. So hold on. Yeah. Hmm. So angles in this cycle are as follows. First of all, we have got angle BDC. Look at where I'm pointing. Angle BDC. D is coming in the center now, right? Angle BDC. Getting it, everyone? This is the angle, and we are naming this as angle BDC. D is the vertex. You see, the vertex has been written in the middle, and the other alphabets have been written left and right of the vertex here. Okay, not? So, what are the arms of the angle? Yeah, Habib and Laksh. What is the arm of the angle BDC?
The arms are DA, DB, and DC.
First, tell me of only angle BDC. What are the arms of angle BDC? So, arm
DB and
BD and
C, DC.
CD. Good. So, arms are ray BD and the ray CD. These are the arms. And the vertex is obviously, vertex is only D now.
Yes, sir.
Getting it. So since we had to name only one, so we have named only one. But there are some other angles in this only, and in that one also. Yeah, this one also, yeah. Name at least one angle, and let's draw the rays also. So where are you going to draw the ray? Where are you going to mark the angles? Yeah. Should we mark an angle over here? Right? You see? Let's take this as the starting point of the two rays. First ray and the second ray. Isn't it? And this is the angle we have got over here. Yeah. Let's call this as O, and accordingly, like, let's call this as M and N. Okay. So what will be the naming of this angle? Tell me, how will you name it? Habib, why have you turned your camera off?
O, M.
You're not participating.
The angle is so
Ang-
MON.
MON, exactly. So that is
MON.
angle MON. Okay. Now, by the way, if you have been noticing that I am writing angle also in short, you see here, instead of writing angle MON, I can also write, like, for angle, I can use a symbol like this. Okay, now that is angle MON. In short, also we can write it in the following manner. Okay, what are the arms? When I say arms, you have to basically mention the rays. So what are the rays in this angle?
OM and ON.
Exactly. So OM and ON. Okay. Then the vertex is obviously.
O.
Oh, the other question I'm leaving it for you guys to do. Okay, now. Now you have to draw and label an angle with arms ST and SR. Okay, na? You have to draw an angle of any measurement, but the arms should be ST and SR. How will you draw it? Think about it, give it a try. You have to draw an angle, okay? And the arms of the angle should be ST and SR. Basically, ST and SR here are, let me give you a hint, ST and SR are rays basically, rays. So we have to draw two rays, ST and SR, that should meet together to form an angle. Give it a try.
Sir, done.
Done? Tell me, show me. I will have to zoom it out. 1 minute. Well done. Very good. Very good. So that is how it has to be drawn, right? So important thing to take care of is that the starting point should be common. And here it is. What's the vertex or the starting point here?
S.
S. So ST and SR. And label it also. So you will be labeling it also. So it is angle TSR. Can we say angle TSR? Right? Or either you can call this as angle RST also. No problem. Angle TSR or angle RST. The same thing. Habib, you there in the class, na?
Yes.
Okay, why not? Why are we not saying anything?
I was quiet because you were explaining.
You are understanding the explanation, no?
Yes.
Okay, now third question, explain why angle APC cannot be labeled as angle P. Yeah, it's a good question. See, angle APC. So you guys tell me, when I say angle angle APC, so is it only this much? Huh? Or is it the other one, or all of it? All of it that I have marked in blue.
All of it.
All of it, exactly. Right now. So angle APC. Look at the arrow where I'm pointing. Right now. Angle APC. So all of it. So can I just label it as angle P? Question is saying that also it's saying that it cannot be. So it is clearly mentioned in the question that it cannot be labeled as angle P. But why can't it be labeled as angle P? That's the question. Because angle APC is a combination of two angles now. You see this angle and this angle. It's a combination of two angles. So that's why that's why we are saying that angle APC cannot be labeled as angle P. Also, there's more than one angle. No? Basically, there's more than one angle at angle P. There's more than one angle at the vertex P, I mean to say. So that is angle APB and angle BPC. Let me write this over here. The answer to the question is that we cannot, or basically angle APC is a combination of two angles. What are those two angles? Can you guys tell me? What are those two angles?
PA and PC.
PAB. PAB. This one. Let me mark it. Look. This angle now. This one. And the other one is this now. The other one is this one. So angle APC is a combination of two angles. Namely, those two angles are a combination of two angles. That is angle APB. Angle APB is representing the one in the blue color. Habib, you're getting it now? Angle APB, this one. And
Yes.
hold on, it's moving too fast. An angle BPC. Right, so it's a combination of two angles, that is angle APB and angle BPC, sorry, BPC, right? So angle APC cannot be labeled as angle P Because we are seeing that simply there are two angles at the same vertex, right? Label as angle P because sorry, because there are more than one angle at vertex P. Look, suppose if I had taken another angle, like in this one, consider this one here. Either you call this as angle TSR or RST, or either you simply call this as angle S, angle S. There is no problem in calling this as angle S because at the vertex S, there's only one angle here. Try to connect this. There's only one angle at vertex S, but here at the vertex P, there are two angles. No? That's why you cannot simply call this as angle P. Let me share the screenshot. Hope it is clear. Quickly save the screenshots because the class is just about to end. By the way, an important thing, yeah, I almost forgot.